Hello everyone, today we are going to talk about how to calculate the density and radius of the crystal structures. We will look at three different cases and three different structures today. The first one, the simple cubic that it's known as SC, then face center cubic or FCC, and finally the body center cubic structure that known as BCC. If we know the atomic weight and the atomic radius of an element, we can calculate its density, and vice versa. If we know the atomic weight and density, we can find the radius of the atom. Okay. In this slide, you see the structures of different structures. The first one is SC that you see at the left side here. You see that we have 8 atoms at the corner, so the number of atoms per unit cell is 8 times 1 per 8 equals 1. So 1 atoms belong in each unit cell. Here you see the FCC. FCC, we have the atom at the center of each surface and 8 atoms at the corners. So the N, or the number of atoms per each unit cell, is 4. That's 8 at the corners times 1 per 8, because 1 per 8 belongs to each cell, plus 6 at the centers of the surfaces. That's half of them definitely belongs to this unit cells, means 6 times half, that be 3. The summations of them will be 4. And finally is BCC, that we have 8 atoms at the corner and 1 at the center, that 100% belong to this cell. So 8 times 1 per 8 is 1, and 1 at the center is 2. So the number of atoms in each unit cell is 2. Okay, here we see the table of different 3 cases that we have. The simple cubic or SC for polonium or PO, the atomic weight is 209 gram per mole. The atomic radius is 0.168 nanometer, and density 9.20 gram per centimeter cube. It is the real density, and now we want to calculate that and compare our calculation density to the real density that we have. Okay. The rho or density, as you saw in previous videos, is N times A per VC times NA. What is N? The number of atoms per or in each unit cell. What is A? Atomic weight. What is VC? The volume of cell. And what is NA? Is the Avogadro number, or the number of atoms in each mole. Okay, look at here. If you remember, I told that for finding the relations between cell dimensions and the radius of the atoms, concentrate on the more packed direction. Okay, the more packed direction is along the cell length. Here, it is A, it is R, and it is R. So A equal to R for this type of structure, or SC that you see here. So R is half of A. We need both of them, and I explain you why. If you remember from previous slide, I told that the number of atoms for SC per each unit cell is 1. So we substitute 1 times atomic weight according to the table 209. Avogadro number, or Na, is 6.022 times 10 to 23. And what is VC? VC is A cube. Instead of A, substitute 2 R's, so it should be 8R cube. And R we have from here 0.168 and substitute here, and it should be 3.79 times 10 to minus 23 centimeter cube. Why? Because it is the nanometers. Nanometers means 10 to minus 9 meter or 10 to minus 7 centimeter. Okay. Substitute here and you find the density as 9.15 gram per centimeter cube. If you compare to the density that we have at the table is 9.20, so close to each other. In next slide, we want to talk about how find the radius by knowing the density. Okay, here, what is VC? According to this fraction, it should be NA divided rho NA. And N was 1A, you substitute from the previous table. Rho substitute from the table. And NA is Avogadro number 6.022 times 10 to 23. Okay, what is this VC? VC for these structures is A cube. A cube, we know A cube, and we know the relation between A and R. As I explained you, A is 2R, so it should be 8R cube for this structure. What is R cube? Is these fractions 1 times A, 8, rho, and Avogadro number. And for R, we need the third root of this fraction. Okay, so by knowing the radius and atomic weight, we can find the density, and vice versa. By knowing the atomic weight and density, we can find the radius of the atom. And we did both for SC. Now let's move to the FCC, or face center cubic structures. If you remember, N was 4 for this type of structure, and I explained you in the first slide why. This equation works for all of the structures. NA divide VCNA. So we know we need N, we need atomic weight, we read from the table, Avogadro number that is constant, you substitute, and VC. What is VC? It is different. Now we should focus on the more packed directions. If you look at that, the diagonal at each surface will be more packed direction. If it is A and it is right angle, triangle, so it should be root 2, and root 2, if no free space here, it should be 4R. So it is the relation root 2A, sorry. The relation between A and R. So how much A is 4 per root 2R, or 2 root 2R. So we know that, read the radius of the atoms from the table here and substitute here. You find A, volume is A cube, substitute A from here, cube, you find that. N for FCC is 4 times the atomic weight from the table, divide by VC, and divide the Avogadro number, and you find 8.96. Back to the table. Okay, for FCC or copper Cu, the density was 8.96, and the density that we derived exactly 8.96. And the last one for the radius, I talk about the radius here too for FCC. If we know density, if we know atomic weight, but we don't know R, what should we do? I explained you root 2A was 4R. So A is 2 root 2R, and A cube or VC should be 8 times 2 root 2R cube, or 16 root 2R cube. You can substitute here instead of VC, 16 root 2R cube. So R cube should be NA 16 root 2 rho and Avogadro number. What about R? Is the third root of this fraction. Only need that you substitute the density and atomic weight, that for this case is Cu or chrome here, and you find the radius. Okay, and finally, calculating the density of crystal structure BCC or body centered cube. Again, if you remember from the first slide, we talked about that the N is 2. We have 8 atoms at the corner. 1 per 8 belongs this unit cells, and 1 at the center. That 100% belong there. Totally is 2. What about the volume? For volume, we need A cube. You should find the relation between A and R. And again, as I talked about that in previous video, we focus on more packed direction. That is the diagonals of the cell. It should be this. And if you remember, it was A root 3, and it is 4R again. So A is 4R root 3. You read the atomic weight from the table. You read the atomic radius from the table. You find A is 4R per root 3 here. And then unit cell volume or VC is A cube here. And substitute in these fractions. N was 2 for BCC, A from the table, and A is Avogadro number that's fixed, and VC is A cube, and we find rho is 0.812. Back to the table again. For potassium or K, it is 0.86, and here we found 0.812. Close, but a little difference. There are several reasons for that. Okay, and the last slide means finding the radius if we're knowing a density or atomic weight. If you remember, again, I explained you A root 3 is 4R, more packed direction, is the diagonal of the cell. So VC is A cube, or 4R per root 3 cubic. It should be 64R cube 3 root 3. Okay? And substitute here. No, we cannot. Okay, substitute here instead of VC. So R cube is NA, rho Avogadro number. And for finding this R is the third root of this fraction. Okay, everyone. Today we talk about and covered SCFCC. BCC, if you are interested to having the free PDF, I put the link for you and you can request and receive the PDF, free PDF about everything that today we covered about that. Thank you so much. Have a good one.